Welcome to today's Explainer. We're diving into a really fascinating piece of source material today that perfectly captures the trial, error, and, honestly, the sheer mystery of working with nature. We'll be looking at a gardening journal entry dated August 8, 2026, by an author named Eng. It's titled, Notes on Gardening, Part 980, The Lessons of Keeping Vincas Alive. So we're going to dissect Eng's meticulous troubleshooting process and see exactly what it takes to crack a botanical cold case.
I mean, really, why do perennial plants just die? If you've ever carefully nurtured a plant, followed absolutely all the rules, and still watched it just mysteriously wither away, you know exactly how frustrating this is. It's kind of the ultimate puzzle, right? You buy a plant that's supposed to stick around, you invest your time, and then out of nowhere, it just starts failing. This relatable frustration is exactly where Eng's journal entry begins, setting up this fantastic little investigation that we're going to decode together.
Okay, let's dive right into Section 1, the Vincas mystery.
So, just to level set, a perennial is a plant that's expected to live and thrive for several years. And I really want to highlight the core irony of Eng's situation here. There's this very specific feeling of betrayal when a perennial decides to suddenly drop its leaves. Because, by definition, these guys are not supposed to be temporary visitors in your garden. They're supposed to be long-term residents. Yet, as Eng points out, despite this perennial label, keeping them alive actually proved to be a massive challenge.
The specific victim in our mystery is catharanthus-roseus. That's the scientific name for the Madagascar periwinkle, though you probably know them as Vincas. Now, according to the journal, Eng isn't a novice with these plants at all. Eng has been keeping and even successfully germinating these Vincas for, quote, quite some moons. So this implies a deep familiarity and a previously successful track record, which, makes the sudden decline of these plants all the more puzzling.
Eng's dilemma is actually highly specific. The mature, potted Vincas are the ones that keep mysteriously dying. Notice the clues we're getting here. The trouble isn't hitting the young seedlings, it specifically targets the mature plants. And not just any mature plants, but specifically the potted ones. In any good investigation, you gotta look at the anomalies. Why the mature ones? Why the potted ones? These are basically the parameters of our botanical crime scene, prompting us to examine every single clue Eng gives us to find the real culprit.
Moving on to Section 2, the fertilizer fallacy.
Now, what's really interesting about this is the stark contrast between conventional wisdom and actual on-the-ground practice. Common advice tells us these plants need light feeding. That's the accepted standard. But Eng's reality? Completely different. Through a bit of recent trial and error, Eng realized that regardless of all that standard advice out there pushing for light feeding, these Vincas actually demand regular fertilization. It's a great reminder that sometimes the standard playbook simply doesn't apply to the unique microenvironment of your own potted plants.
Which brings us to Section 3, the drainage dilemma.
So, while fertilizer was definitely one piece of the puzzle, Eng discovered that the physical setup of the mature potted plants was hiding the primary suspect. Let's look at the forensic clues left at the scene. The symptoms plaguing these mature Vincas are very specific: yellowing leaves and poor blooming. When you see poor blooming on a vibrant flowering plant like a Madagascar periwinkle, and combine that with leaves losing their vital green color, well, the plant is essentially screaming that it's in severe distress. But what's actually causing it?
It turns out this tragic sequence of events happens entirely out of sight, underground. And it starts with poor drainage. Step 1. Excess moisture accumulates in the pot. Because the water has nowhere to go, we hit Step 2. The roots suffocate. They are literally drowning in the soil. And finally, Step 3, which is the visible outcome, the bottom leaves turn yellow and drop off. Eng's journal lays out this exact sequence, explaining how that hidden underground damage directly translates to the heartbreaking symptoms we see above ground.
But here is where the mystery gets incredibly frustrating. Eng makes this fascinating observation. A nearly identical issue, the yellowing and dropping of leaves, can also happen with underwatering. It's kind of the ultimate Goldilocks problem of plant care. Drowning the roots and parching the roots cause the exact same visible symptoms. Think about it. If you misdiagnose those yellow leaves as a sign of thirst and add more water to an already drowning plant, you're just accelerating its demise.
So the crucial point is captured perfectly in Eng's journal right here. Thus, we need to balance our watering routine and remove plant saucers, especially during the rainy season. This is Eng's actionable solution. To break that cycle of root suffocation, especially when the weather is unpredictable and raining heavily, you have to physically remove those plant saucers. Those little saucers just trap the excess moisture right at the base of the pot, turning what might be just slightly poor drainage into a fatal flaw.
And that leads us to Section 4. The wild sandy solution.
Now that the culprits have been identified, incorrect fertilization and poor drainage leading to root suffocation, we arrive at Ang's recovery blueprint. And the parameters of this botanical experiment are just fantastic. First, transplant the survivors to a larger pot, giving those suffocated roots more room to breathe. Second, use a completely different potting mix to ensure that whole drainage dilemma is solved. And finally, my favorite, most adventurous detail of the entire journal entry, add a sandy mix harvested from the wild. Ang isn't just relying on store-bought solutions anymore. By foraging a wild sandy mix, Ang is actively engineering a custom environment to ensure these plants finally get the drainage they so desperately need.
But as is the case with all great serialized journal entries, we're left on a bit of a cliffhanger. Ang notes that we just have to wait to see how the surviving batch of Vincas will fare in the coming weeks with this new wild sandy mix and larger pot. The entry literally ends with "till the next post." So we're kept in suspense. Will this wild sandy mix finally break the curse of the dying perennials? Will that regular fertilization pay off? We, along with Ang, just have to wait and see.
So it leaves us with this question: how will you adapt to your own plant failures? Ang's meticulous analytical approach is honestly a perfect template. Ang didn't just throw the plants away. Ang observed the symptoms, questioned the conventional wisdom about fertilizer, deduced the mechanical failure of the plant saucers during the rainy season, and then engineered a really creative, wild solution. The next time a project or a plant fails on you, I want you to remember Ang's Vincas. Investigate the clues, challenge the common advice, and hey, don't be afraid to try your own wild sandy solution. Thanks for joining me on this explainer today, and keep exploring.